Hello. Hopefully, I'm live and can be heard. Okay, so another new project today, but hopefully this one won't take too long. Maybe, hopefully this and then maybe one or two to deploy it. But you might have heard of the 1 million checkboxes, which was a project where you have, well, as you can see, 1 million checkboxes, and the idea is that anybody in the world can can check one of these checkboxes, and then it would check it for everybody else. So it's not turned off at the moment. It's been sunset. I'm not sure what the reason behind the colors is, but you get the idea. So every time, let's say, I scroll down here and I check this box, within hopefully some relatively small amount of time, that box would be checked for everybody else who was doing it. And the guy who made it wrote a very interesting blog post about how it worked and the scale. Oh, I thought it was longer than that. Anyway, somewhere or other there was a I think this is what I was thinking of. Anyway, how we scaled it up, and how the architecture worked. He was using Redis, which originally with several Flask servers behind an Nginx proxy, and then switched over to using Go servers, which made a big difference in performance, as you might be able to imagine. So I thought this is a really interesting thing, and I had some ideas on how I would do it. So I thought it'd be fun to implement it, but to make it a little bit different, instead of making it checkboxes, making it sliders. So the idea is that they can go between 0 and 255, and that you could have a whole bunch of them, and then hopefully have a single server that would be able to manage a reasonable amount of them, and then maybe I can, if I spin it up, and then I can try some load testing and see how well it performs. So the main thing is how you do the updates and how you do the batching, because if you send the whole state, so for the checkboxes, that's 125 kilobytes, and for this project it will be a megabyte. And so if you're sending that a lot, that gets to be a lot of bandwidth very quickly. And so the point is, how can we optimize that? How can we send incremental updates? And then how can we batch those together? So my idea is that we have a single in-memory thing which stores all of them. So it would be a buffer, an array of U8s, which is, I guess, 1 million long in the end. Probably start a bit smaller than that. And so that's the state. And so there'll be one process which controls that, and then it gets sent patches and it updates them, and then it writes the patches into a circular array. And then what you can do is that you have a process or a task for each thing that's connected, and then occasionally, either on a timer or on request, and every time, and then there's an epoch counter that gets incremented every time you increase you make a change. So then the idea was that you can say, well, what's the count of the current state of this machine? And then we keep a buffer of a certain number, I don't know, maybe 100, maybe 1,000 changes, and then we say, well, if the state that it's currently on is less distance than that away, is within a certain range of the current one, then we'll bundle all of the updates down and send those. Or if it's too far, then we just send the whole state again. So that's the general idea. I think an interesting, more sophisticated thing would be with quad trees and things like that, and only sending the ones that are required. But I think it's more, well, I think this would be an interesting place to start. But I think one of the interesting problems will be how to reduce coordination, because if you lock the if you have a read-write lock on the array and you have patches coming in very quickly, then that's going to cause problems. So I was thinking of implementing it as a left-right. So yeah, although I can't remember the can't remember everything about the implementation of those, but I think that would be an interesting thing to try. So let's make a new project. So I think just I don't know, can't think of any. Oh, didn't know that. Okay, very creative name, I know. Also thinking of one and a large number, planning to make. I've been doing some work on my own of the 1 billion rows challenge. I got a Zig implementation, which is just very rough first pass, but is still decently fast. So I was thinking I might do some stream working on that, and possibly a Rust one to see what difference, how they compare. I did start working on a Rust version ages ago, but it'll be interesting to see how terrible that is. Okay, so I will so in here we're just gonna start the server and then do the WebSocket stuff, so I'll probably use Axum for that. And then oh wait, no, I want RS mod. So in here, I think we're going to want. So this is going to be slider num, which is usize. So we should be able to make this 100 for now. Then we can scale it up to 1 million, and hopefully things work similarly. Oh yeah. Okay, so the question is whether to put it in lock. So I suppose that would be the obvious way of starting. So let's do don't know whether we really want this to be async. That'd be an interesting thing. But anyway, So if we start it, so then sorry. The other thing that I was going to say is that one of the issues with the 1 million checkbox things was in general the representation. Well, it was a bit array, but in generally sending the information was relatively inefficient. So I had an idea of how to do this. Let me add this to the was that basically we need to store the index, so the number of the checkbox or whatever it is, and then some information about the state. And so what we could do is add a struct, so I'll call this a patch, and it just contains a U64. I don't know if this actually makes any difference. And then the idea is that we can then use bit shifting to get the things out of it. So contains index in bits 0 to 23 and state in 24 to 31. So what we can do, so let's do new. So then we want state is going to be a U8. And then we have index, and that's going to be a I don't think you have U24s in Rust, so oh no, it doesn't need to be a U64, sorry, it only needs to be a U32. Right. Right, and then we want to go to a patch. Right, so then I think what we want to do is to let equals, we want to go state as U32, and then we want to move bit 0 into bit 24. So I think we want to do that. And then we want to do we just want to AND them. So we want index, sorry, I don't mean AND, I mean OR, state shifted. The only problem is if the if the input state is larger than has bits more in bit 24. So I suppose what I could do is let me go debug assert that index is less than 1. Yeah, because if it's 0, yeah, so that should be right. Okay, so we should be fine then, and then we'll just do patch out. And then we can do so I guess we can, if we wanted to get both, we can have an unpack, and then we can also have separate ones. So let's do state. This takes reference to self, and then we want to return a U8. So what we want to do is let so we want to do self.0, and then we want to shift that right by 24. And then we want to mask that with 8 bits. So I'm pretty sure because F is 15, so that's going to be 4. So I think we want to do shifted and 0xff. Right. So, well, actually, I wonder if I could just I wonder if this would work. I'll write some tests in a minute for this. Okay, and then index self. Now we want U32. So now what we want to do is we want to zero out those first 8 bits. So I think the best way to do that would be so this is going to be, but we want to shift it. So that's going to be from bits 0 to 7. So we want to shift this to the left by 24. And so that's one where we don't want it. So I think we want not that. So now that should be 1s only where we want it to be. So then we can just do self.0 and mask. Let's add. Okay. So I can never remember the. So let's just add some tests here to make sure I haven't messed up. Test and okay, so I don't know. Just do the basic test. So let's do let state U8 equals 42. And then let index, this is going to be a U32 equals, I don't know, 6615. So then what we want to do is let patch equals patch new, and then assert equal state and patch dot state, and then index and patch dot index. Ah. Well, that seems good. And then let me just do oh well, no, I'm sure that's fine. Okay, so that means that so this is our state, which we want to be a U8 and of what did we call this? Slider num. Slider num, and that equals 0. Oh, that needs to be a semicolon. Okay, and then I think U64 will probably be fine. So that starts at 0. There's definitely going to need to be some atomics in here at some point. Though might also be able to, if you do everything through channels, that might also work. Have to see, because all what we could do is have the because we should the patch buffer, you could add a if you make it a double-ended, make it an actual ring buffer, then you could atomically, then you just need an atomic start and end pointer, and you could progress the end one, and so then that could just be shared state, and then that's lock-free. So then we could just have only then this process just receives write requests or makes copies of it. I think that should work. Okay. So let's do so yeah, the epoch count is fine. Oh yeah, and then so the idea is the well, this would be shared, but the patches would basically be this. Sorry. I'll just call it effective for now. But the idea is that it would be of the patches, and then what you could do is you could say, oh, I want to find all the patches between these epoch numbers, and then you could iterate through those. Yeah, just thinking that should be just need to be careful of race conditions if you're reading the last element. So if you have a you have your memory cells, and then let's say you have a I don't know how to do an arrow pointing down. Anyway, so this is your end pointer here, and then say I check where this is, and I was like, oh great, okay, I can read from here. And then while you're reading from this pointer gets moved atomically over here. but then that's no good. Not sure how to solve that. Okay, I think I might have to do... I'll check how the... I feel like the left-right trick might work for this as well. I'll need to check how that works. It's the kind of thing that once you get it, oh yes, of course, that's how it works. And then when you try and remember, oh, okay. Well, let me just do this now. Okay. So in here, let's do struct, and then let's just do, I just got a ring. So what we need is a buff, which is going to be, I'll just make it not an associated ring size. Let's call this 100. I'll do 10 for now. U size. So then we want this is going to be, well, let's make it generic. I don't think there's any reason not to. T and of ring size. Okay, and then we need the start. No, that's actually going to have to be unsafe cells, I think. So the start IDX is going to be atomic U size. And then we want the and IDX. Oh no, I really should make this U size. Okay, let's do it like that. Yeah, so I think unsafe cell is what we're going to need here. So unsafe cell T. T. So then what do we need in the API? So let's do the reading methods first. So let's just do a get. So now the point is that we might have very high indices, but they'll always go wrap around, and that's the idea. But we're always going to need what the last index actually is. So rather the epoch. Because forgot about that. Okay, so really this is not index, this is epoch. And then we want an option, option T. Oh yeah, this is going to be size. Oh well, the epoch was 64, so I guess we want that. So first let's get, well, if the epoch is less than end self dot. Oh, I forgot to do self. Self dot end epoch dot no, it's load. Then oh wait, we want it's all standard sync atomic ordering. Oh no. So then we want to return none. Oh no, this would be U64. How's that? Okay, so that makes sense. And then let's do let index. This is going to be epoch mod s. Oh yeah, okay. So now we just need to check that it's between them, but they could have wrapped around, because we could have the, so what did I call them? Start and end. So initially, we'll have like the start here and the end here. And so if anything is greater than the start and less than the end, then that's fine. But as we go, we'll move these along, and then we might end up in a situation like, oh, that's not what I want. Like this. And so if we're reading this one, then it's fine. What's the way to get around that? Well, what if so we know that well, obviously if it's equal to S, then that's always valid, and if it's equal to E, then it's always invalid. So I feel like, is there anything that works in all cases? So if it's so okay, let's have I feel like the two cases are that they're inverted or in normal, sort of in initial order. So let's consider the two cases. Okay. So in this case, if it's greater than if it's greater than greater than or equal to s and less than the end, then it's good. And here it's if right, and s is less than or equal to e, or so in this case, it either needs to be so if s is greater than if they're equal, then it doesn't really matter because everything's valid. So if s is greater than e and I is greater than or equal to s, or I is less than e. Okay. I feel like there's got to be a simpler way to do that. Thinking, what if you you could maybe you could add the okay, well I'll try this. Oh, that's what I want. Okay, so if so, I wonder if I could invert. Oh, yeah, I could probably. But I'll just do this for now. So if let me do s equals self.rdx dot load ordering and then we're gonna have so this is the critical section where you'd have the time of use time of check, time of use. So the problem is that we're checking here whether this is a valid read. But then that's not atomic with the read itself. I suppose could do is that it's always going to be initialized memory. So what if we... Now, this doesn't work for the iterator approach necessarily, but what if we just read it first, optimistically, and then check if it's valid. I mean, you could still theoretically... Yeah, but then what if it gets written into? I guess you have the problem in the other direction. Yeah, no, maybe this won't work. Let me think. Yeah, no, I think this will have to be... Will have to be the... So also have to be behind a left, right, or something like that. Because... Unless there's some kind of... more fine-grained locking, but I don't think... So yeah, no, I was thinking... I think the fine-grained locking would only really work on the... on the global state. They don't need to do locking. I mean, we could always just... If we made them atomic... And it would be sort of last... last person wins. You could just make that static and let anybody write into it. The problem you then have is how do you know what updates to do? Because we're not sending the whole thing every time. Yeah, so we still need, even if we did do that, we'd still need some kind of mechanism to do this. Well, I mean, it's effectively pub sub. So what I might do for now is why don't we let's well, I guess we can still keep this, but then just make it a vectec. And if we do everything with channels for now, then we don't have to worry about it. So yeah, I guess we need to do So let's do we'd want sync MPSC receiver, and then so no, we need to so what could we have? So we could have a patch, and that would contain a patch. We could have a state request. And so that would contain a one-shot sender of vec-u8. So we could reply with that. And then we could do incremental. And so that would contain the epoch number that we want to and then that would be yeah, so what do we do if it's too old for an incremental? I mean, you might as well just send the state immediately. So, I guess we can do it as a result, can't we? So let's do result, and then if we can do an incremental, then we'll do vec u60. No, rather vec patch, and then otherwise it's going to be a vec u8. Okay, that makes sense. So in here, import print message. So then we want to do while let some message equals rx dot don't know if there's any is there any reason to use receive many over just receive? I'll just use this for now. And then we want to go match message. That's why. Wait. Okay. So if it's a patch, then what we want to do is we want to go state patch dot index equals patch dot state as usize. Oh right, we need to make this mute. State request. Okay, so here what we want to do is we want to let send vec equals state dot to owned. Oh, that doesn't. To own doesn't. Let's try vec from state. Does that work? Okay. So then we just need to go tx.send yeah, send back dot. Do we? Which was it? So do you need to? Okay, this is the enjoy these things. I'll just go. We'll just so if it doesn't work, ignore. Well, for now we'll unwrap it. It's not really. Okay, so then here we should do the epoch and the tx. So no, we want to do with capacity, and then we want to do const patch cap equals, well, let's call it 100 for now. Needs to be usize. Cool. So now what we can do is, so we want to see if we can do an do it incrementally. So so if the epoch is less than epoch and e is greater than epoch minus patch cap let's see, else. So if that doesn't work, then we want to do that as u64. Oh right, let me impl debug for patch. So field Um, yeah, it's more like, so this is still patch, and then dot field. This is going to be index, and then the value is going to be self dot index. Oh, and we need that to be a reference, and then dot dot field, and this is going to be state and reference self dot state, and then finish. Where are we? Okay, cool. Okay, so if it is fine, then what we're going to do is that the index equal the e as maybe I should just make them use SZU64 mod patch cap. So let me check the vecdeck. So yeah, I want to iterate over them, but only from certain. But it's in the. I don't know if that will actually. Because it's 0 is always the sort of logically the first element in the list, but I want to refer to things sort of by where they actually are in the buffer. So maybe I will have to. Okay, let me. Because I only care about pushing new elements. Let me. So. Just need to be okay. So the buffer is now this doesn't need integer immutability or anything. So it's just going to be ts, and then we want the I guess I'll call it end. So that's the one after. Okay. I think that should be fine actually. Okay. So now import t so now we want to do new I don't know if you can do that. Oh yeah, I need the const s u size s. Okay, cool. So that does work. So if it is default, so then it's going to be ring. Oh no, never seen it do that before. Okay, so then this is going to be a t default s, and that is going to be 0. Oh yeah, I want to return a. That should be. Oh, interesting. It needs to be copy. Oh, that's fine. So I guess on here I just need to derive. Don't want debug. I want default and clone and copy. Good. Okay. I'll read that for now. Okay, so that's how I can make a new one. So now I want so let's say push. So this is going to take a mutable reference to self, and then yeah, just a value which is going to be a t, and doesn't return anything, and yeah, so then let's say end is always less than s. So then we can just say that self.buff self.end equals value, and then self.end equals self.end. Well, I suppose I can just do plus equals 1 self.end mod equals s. That makes sense. Cool. So then that, I think that ensures that that's done. Okay. So then what we can do is, well, let's just do get to try use size. So that's just going to be this is going to be that. So index is going to be epoch mod s as usize mod s. So now we have the index, and we're saying that they're all valid. So that's fine. So we just need to then, oh, right, so this is going to return a t, or a reference to a t. And then we can just do reference to self.buff index. Okay, so now what we want to do is then to get a copy from, so then this will be self, and then epoch again, but this time we'll return a vec of t. So yeah, so we don't actually check that the yeah, we should probably do that in here. Okay, so then we do epoch u64 yeah, but then I'm storing it in multiple places. Yeah, I feel like adding them all together as one struct might make the most sense. So I can do that all together. Okay, so let's say that we don't actually do any validation in here. Makes, I think, life simpler. So then what we want to do is say let's do this again. This will get the index, and then let len equal, and so this is going to be if index is less than self.end, then it's going to be self.end minus index, else so where are we starting? So yeah, so here it would just be, so this is 1, 2, 3, 4. 4 minus 1 is 1, 2, 3. That's perfect. So here we have 1, 2, 3, 4 things. 2, 3, 4, 5, 6, 7. That's a bit weird, but why did I make it 8? I'll actually make it something that... Okay, so now we have 1, 2, 3, 4, 5 is what the length should be. And so so we have 1, 2, 3, 4. That equals 4. E equals 1. S equals 8. And so len here equals 5. So what if we added, yes, yeah, I think that works. If we, let's imagine that this did actually wrap around, and so the end is really at 9. So if you add these together and then subtract s, so it's e, oh, that's confusing. I've got upper and lowercase s. This is going to be self dot end plus s minus index. And yeah, I think that's fine. So then what I want to do is I want to go let mute accumulator equals no, I want with capacity len, and then we'll return that. And then I want to say so let mute I equals index, and then while I is less yeah, so what because it's not when it's less than, it's well, I suppose you could just do it dot push ourselves buff I plus equals 1 I equals s self dot yeah, I think that's, yeah, I feel like we could also do because if we know that self dot, so if we're in this case, then we could so here, well, maybe we don't even need that. So let so we could just do vec from and then we should be able to do, this would be index dot dot self dot end, that'd be exclusive. Do we need a reference? Does it? Ah, right. Okay. Clone. Okay. So that seems to work. So here I probably do want to do that here. And then I want to do dot extend so that's going to be self dot buff and then that's going to go from index to s, Oh. How? I guess just cloned. Or could I just go? I always get confused about when Intuit actually works. Well, like when it actually does something that's owned. Okay, that does seem to work. And then we just want to extend it from 0 to end. Self.end. Cool. Okay. So then what we should be able to do here is change this to be a ring. Patch gap, and then patch equals ring new. Cool. So then in here, yeah, if we can, then we just want to do patches dot copy from, and that's going to be E, and then and then yeah, just tx dot send. Okay, send back. State. Ah, right. Okay, so I need to ooh. That's not what I meant to do. Okay, so then the point is that every time we get a right, so here we want to increment the epoch, patch the state, and then we want to go patches dot push the patch. Okay, so now I'm just thinking about what to do next, whether I should implement the server. That seems like a reasonable idea. And okay, so let's have a look in the I have more experience in Axum just because. So yeah, let me make another. Let me make a start function here to start the server and stuff. So start so let's do first Rx equals, you want MPSC channel and then let's do Tokyo spawn state manager start, then we want manager RX, oh wait, let's do, I don't know, let's just do 100 for now, we can figure that out. Cool, so remember how to do this. So I think we want, so let app equals router new, so dot root, so let's do so let's call this hatch handler, so async fn batch handler, so we'll want an extractor, wait, I think I did this in maybe I did it in, sorry, let's see, just trying to remember how I yeah, it just was just and extension. Okay, so why isn't that? Oh, it's extension, not extractor. Extension. And yeah, I want a ESC sender message, and then I want body that's if I just do things over if I just do them over HTTP, then that makes it easy to check with curl, and then I can add WebSockets later. And then I want to how do you layer extension? Okay, layer extension. Extension. Oh, I need to. Right. Well, should that really be get? What are the there's get head post put. Patch. I feel like patch would be the patch, and then patch handler. There are also okay. Type annotations. Wait, does this? Maybe it's this. Me derive. But I don't really want it to be cloned, do I? So I don't think these are clone. So what's oh, okay, yeah, maybe if I put in the rest of it. So let listener equal Tokyo net TCP listener bind 0.0.0 colon I don't think 1 million is a port, so let's go with 1,000, and then XM serve. Then we want listener app dot await dot unwrap. Cool, and that sorted out the trade things. Cool. Okay, so then we all we need to do in here is how do we get right, because it really should just be 4 bytes. so how do we um, is there a bytes? That seems right. So I guess how do you is there a U64 oh, that's native. Let me see, what's the network byte order? Big endian, okay. So we want from big endian bytes so this is so can we just do body 04 like that? Oh yeah, we want U32, don't we? Okay, so what should I call this? So now we want a U8 4 equals body so dot into, can we do that? It should be copyright. So can we go? So how can we write to a okay. Okay. How do you convert it into array? Okay. So try into. Okay, so that works. Yeah, if it's let me see though, because if we have can you have body dot because what does this actually implement? implement, because it'd be nice if you could see if it was either. Yeah, no, I don't think you can. Okay, no, that's fine. So we'll just do bytes, and then oh yeah, so let's do bytes, and then we well, I guess we can just make that pub, and so here we want to do dot send, and this is going to be message patch, and then patch. So it's a bit comical, but there we are. Okay. So now we just need to do something similar for we don't want this to be patch. I'll just call this incremental. 8. Yes, I need to switch this to 64. Cool. So then this one we actually need to respond to. Into response. So let tx orx equal one shot channel, and then what we want to do is we want to we message incremental, not patch. This is start, or I guess maybe current. And so use current, and then this is going to be OTX. And then we want to do ORX dot await. So what is that? Let res equals ORX dot await unwrap. Right. So I actually want to match that. So if it's okay, So I guess I can do it with the response code. So 200 is okay. But I can use one of the other if I use another 200 ones, then that should be fine. Maybe I'll use 206 if it succeeds, actually. So if it's okay, then that's yeah. So then I want to do yeah, I'm gonna have to turn them into bytes to so how do I do that? I mean, I guess just dot into iter and then so this is p dot 0 dot to big endian bytes dot flatten dot collect. This is going to be a vec u8. Though I could probably do this with a flat map, I think. Excellent. Okay. So then I just need to do status code, partial content, bytes, dot into response, and I'm gonna change this to be response. Cool. Oh yeah. Don't need that. Excellent. So then this is going to be full. Well, I suppose this is more like an update in general, and then oh, I didn't add it yet. So full, so that's going to be then let out vacuum8. Now I want to go full dot into iter dot flat map, and this time it can just be u64 to big endian bytes dot collect. That should oh no, that's fine. I don't need to do anything. I can just do this is going to be okay. Full into response. Oh, that should be it. Though I suppose that's update, and then so let me add that. So this is going to be the update handler, and this is going to be get, and then state. Let me do state handler, and that will be similar, except it will just always return everything. So we don't care about the body, we don't expect it to have anything. We want this to be state request. Oh wait, I should have state request, and then we can get rid of that. And then it should just be the status code okay, and then orx dot await dot unwrap. Dot and then int response. Cool. So let me just check how many. Oh right, then I actually need to. I'll just do everything I think for now. No, wait. Start dot, and that's a bit redundant, but if we do more CLI stuff, then I will do that. Okay. So now if I guess this probably makes this easier if it isn't too jumbled up. So here I want local host 1000 perhaps no, that's fine. Then let's just do dash state and then if I do update oh yeah, that's binary structure file. How can I do? Needs to be so I probably shouldn't get. Oh no, that's not true because I put a. If I let me do if I put. Let's try that. Okay, well it seems to be sending them all anyway, so I think that's a bug. Okay, but let's try. I'm not sure what. So if I do, there's 4. So then the first one will be the mount. So let's do 7, 0, 0, 1. And the length is 100. Indexes. Let's see. Yeah, I think that's. Okay, well, it's pretty late, so I think I should probably go to bed now. I think most of it, the idea, I think, is there. I think what I'll do is I'll add command line stuff, so I can send patches and then see it, and then add WebSockets. So then, if I can get it working on a terminal, displaying and then probably sending patches separately. And then I think I'll look into using Leptos to do the front end. Great. Well, thank you for watching. This is interesting. I hope you found it interesting. And yeah, I'll keep working on this soon.